Hello, my name is Ashley Stewart and welcome to my final project presentation. I have learned a lot this semester and now I get to talk about some of those things. Specifically, I'd like to begin where the rubric does and refer to the first thing, which reads, explain the difference between the static class variable and a class instance variable. Give examples of code showing how to reference and call a static function versus a non-static function. So the keyword static that's found right here essentially means that the member of the class that you are referencing does not need to have any of the objects of its instance class or of its class created. This means that a copy of that variable is made for all the objects to share. The most common example would be in the main, or the quest in my case. You can reference things from a static context because the game has to call the Java virtual machine to run the program. When you are referencing a static function, you use it like found in game control, like the class name and then dot, and then in this case it's a function or method name that's passing arguments. And it's not necessarily a variable, but the concepts are still the same here. This is an example of the static reference. When you are referencing a class instance variable or a non-static class variable, you can only access it from the actual instance that it was created. In main, you can reference the things from a static context because it is referencing all of the instances of that variable. So then in each class you can be more specific. The next thing that I'm going to talk about is the next part of the rubric, which reads, demonstrate through examples from your program your understanding of when to use an array versus an array list versus an enum. So understanding when to use these types of lists constitutes knowing their purpose. An enum is something that is fixed, something that will be the same no matter what. And an array list is the opposite in the sense that it's dynamic and it's always changing. You can add stuff to it and you can change what each value of the items are. And an array list, or an array, is fixed in length. So, for the analogy that I wanted to use, I'm going to use it like a grocery shopping list. An enum would be something like, I'm going to go to the store and I'm going to buy the same amount of items by the same brands at the same price every single time I go grocery shopping. The same thing every single time. So in my case, we used an enum for actor here. Because all of the actors are going to be the same for each, their description is going to be the same for each actor, and the location will be the same, and the name will be the same for each individual actor in the actor enum. So, in this case, we chose to have an actor enum, and each actor that would have the same description and be placed in the same room, so this location, on the map, no matter who is playing or how many times they played. An array list would be something like, going back to my grocery shopping analogy, something like I may get 10 items at the store, or I might get 50 items, and their prices might be different, and like the type of grocery might be different every single time. Something that is distinctly different about array lists are that the items in my cart, essentially, are all referenced as objects, because they could be different kinds of groceries. So in my case, in our code, in this case we have used an array list, and that's in backpack control. Here, where it says the credits, because they can be different data types, but also because we need to, we have to use this array list because we need to add items to the backpack as the game is going. And so it needs to be an ever-changing list of things. So going back to the grocery analogy, an array would be something like, every time I go to the store, I want to get 15 items, right? A fixed amount of items every time I go. but I want them all to be dairy products. I want them all to be the same type of grocery. So in this case, we have implemented an array of questions in the question control class. Excuse me. This means that all the questions that are stored in the arrays, so here, can be easily accessed or referenced whenever the time comes that we need to access them. And they're all the same type, of question, or not the same type of question, the same data type, excuse me. And so that's why, that was the example of the array in our program. So the next thing that I'm going to talk about is the next part of the rubric, which reads, demonstrate through examples of code that you wrote for an individual assignment your understanding of how to use a basic for statement and an index to go through and access each element stored in an array or array list. So an index, when you're talking about an array or an array list, an index refers to the unique identifier of an item that's stored in the array. A for statement allows us to go through each individual index of the array and access or do whatever we need to, like, to the index itself. So in my case, an example of a for statement can be found in my map class. Perfect, just scroll right down to it. These for statements here will go through each individual part of the locations array here. So, for just further explanation, the first one is for, or the I is for the building, and J is for floor, or I said that backwards. I is for floor and J is for building. So, these variables are just placeholders to represent the location on the map. But right here it says your variable I is, as long as your variable I is 0, and your I is less than the amount of floors that we have, which we set in a different class, we're gonna keep adding more I's, and then it will be 1, or then it will be 2, and so on and so forth. So, so this is why it's kind of called a loop, because it will repeat this process as long as the conditions that are in here are met and they are true. And that's why it's sometimes called a loop, because it will just go in a circle and it won't exit until the conditions are false. So in this example, a new location is created, and it assigns that number to those buildings and the floor, and tells us that it's false, that it has been visited. So the next thing that I'm going to talk about is the next part of the rubric, which says demonstrate through examples of code that you wrote for an individual assignment your understanding of how to throw, propagate, and catch custom runtime errors in the program. So in order to throw, propagate, and catch custom runtime errors, you need to have a specific class where you can throw your errors to. So that's what these classes look like, the exception classes. A great thing about implementing your own exception handling is that you can customize the output to say exactly what you want, the specific error that you know that it is. Error, this is exactly where the program malfunctioned. So for one of my individual assignments, I created, technically I created all the exception classes, but for this example, I will refer to the question control exception class. The function I added in riddle view, let me just drag this out for a second. The function I added in riddle view, let's find that. So this function here, the getMask function, throws a question control exception, so it throws to that class we were just in. And this extends an exception package that comes shipped with Java. And the riddle view function basically throws an exception to the question control class, and then in the riddle control class, gotta find that real quick. It says, okay, I'm gonna try running this code. So that's the getMass function that throws to the question control exception. And I'm gonna try and run this code, and if there's an an error, I'm gonna catch it with this class, and I'm gonna display this class the name and the message that's stored in the errorView.display. So I added this logic to riddle control. Sorry, excuse me. To try the function and catch the runtime errors with the prompt from the error view message that's here, right here. So the next thing is explain when and why a character stream class would be used versus a byte stream class to read and write data to a file. So to my understanding, a stream is a way of reading, for lack of a better term, the file. It can be streamed to any kind of storage device, so it can be written on a hard drive, it can be written on a text file. The different kinds of streams basically mean that there are different ways to sequentially read the file. For an example, byte stream means that the computer will read the file byte by byte. And so this would be really good this is essential for binary data, because it needs to be read byte by byte. And, but on the other hand, a character stream means that the computer will read the file character by character, which essentially means that the character stream can be more efficient when there's like a lot of input and output. So the character streams can read the ASCII characters and like so that kind of stuff, but it also has Unicode, and Unicode includes characters from other languages. And in our case, we use character stream because it has the capability to print a report to a text file or a console. So this last thing here, it's walk through an example of code that you have implemented for an individual assignment and demonstrate your understanding of how to write character data to an external file. So in my case, the character data written to a file is quite literal. My characters, quote unquote, are my actors, but my character data is based on the information about my actors. In this case, my external file is chosen by the user, and the program will print a report based on the file the user chose. And the report will be of the actors, and it will print all the actors in this enum that I created here. So if I ran my code from the help menu view, and and I said I want to print a report, it would do that for me. It would prompt my user to enter the file path for where the actor report is to be saved, and then it would save it to the program. The program will just ask the user what I want to name the external file that I'm creating, and then it will print this list. So thank you for listening to my presentation. I have worked really hard to understand the concepts and implementation of object-oriented programming. I know I don't have a perfect understanding, and I'm still willing to learn about it, but I'm so grateful for all the things that I've learned this semester. And I know I'm not like trying to get points for this, but I just on a personal note, I wanted to thank Brother Jones for all of his preparation and guidance, and you have seriously instilled like a lot of new skills and knowledge in me, and I'm so grateful for that. So thank you for everything, and thanks for watching.